that's really the heart of the scientific method. It's how we arrive at conclusions. Of course, the Greeks just used their observations as reason. They didn't test them. So, emphasis on experimentation. So, the nice thing about this slide, it kind of goes around in a circle. So, you basically start with an observation, but you might come into this loop anywhere, and you come up with a tentative reason why you're observing what you're observing, and then you test it, and your experiment will either confirm or deny, disprove your hypothesis, and then you might want to change the experiment a little bit and test it again and see what happens. And you might circle around there for a while, and same thing here. So we see two things going on. We have theories and laws. What's the difference between a theory and a law? I think we've covered some of these. Hypothesis, a tentative interpretation of the observation. I didn't say this though. A good hypothesis is falsifiable. I mean, you can say, oh, life's this way, but if you can't test that this way, it might be philosophy or religion or something that you can't test, right? A good hypothesis is, I can go do an experiment, see if my hypothesis is good or bad. All right, and then if you falsify it, you can come up with more testing. All right, so the difference between laws and theories. It says here, laws summarize the results of a large number of observations and predictions and predicts future ones. I got all tangled up with my words, so I brought in some water. Theories are models that explain behavior. That's what I like to say. We want to know how something works, and we've done experiments, and we say, well, we have this theory that would explain why it's working the way it's working. So I really like the word models. All right. So a law, it says it predicts future ones. I like to tell students that many times a law might have an equation or numbers, and you can do a calculation and predict something. So we're going to look at a famous scientist, Isaac Newton. He's the discoverer of what? Oh, say it a little louder. Gravity. Yeah, when I was a kid, that's the dumbest story ever. Sitting under a tree and an apple falls, just move. Gravity. Now, anybody who's infants understand gravity, right? Well, so what did he do? Well, he observed that everything falls. Everybody observes. But he said gravity acts the same on all bodies. What does that mean, the same? At his time, people said heavier objects fall faster. That's true. They have a neat physics toy downstairs. I wish I was a physicist. They have a bunch of cool toys and nothing stinks and nothing's toxic. I got a toxic dump and everything stinks and it's all toxic. All right. So he found that everything falls at the same rate of acceleration. This is like a gravitational constant. Here's the metric one. Here is the English one. Gravity is going to cause something to accelerate at 32 feet per second squared. Don't want to have a big physics discussion, but when I was younger, they'd say you throw a rock down a mine shaft and count how many seconds it falls, and if you know how many seconds, use something like this and calculate the distance. All right, so he came up with a number. So we say the law of gravity. He discovered the law of gravity. Last semester, none of my Oakham students knew who Louis Pasteur was, and I was kind of heartbroken. How many of you have ever heard of Louis Pasteur before? All right, one of you. Well, if you go to the store, you might look at orange juice, you might look at milk, and it says on the bottle, pasteurized, named after this guy. So before Louis Pasteur, they thought there was this thing called spontaneous generation, and flies and nasty things like maggots would just appear magically, and he came up with this hypothesis. He might have called it germ theory. He had a theory, a model by why he was observing what he was observing. Microorganisms in the air are the cause food to spoil. And so he did experiments where he would boil milk, seal it off from the air, have a control, some milk you didn't seal off, and which spoiled first? The one that wasn't pasteurized. So why do we put so much emphasis on the scientific method? Bleeding people with leeches isn't too healthy. Rest in peace, President George Washington. Yeah, they used to think, oh, if you're sick, it's because you got bad blood. That's what you have when you can't forgive some bad blood. So he got sick, and they said, well, let's give you some medicine, and they gave him mercury salts. Isn't that horrible? And the idea was the mercury would kill, I don't know, off the bad blood, and they bled him with leeches. So that was the practice, or bloodletting. I don't know if they bled him with how they did it. Anyway, a lot of historians say he probably died from loss of blood. All right, so scientific methods are important. Now we know you need all the blood you get. If you're sick, it could be a virus, it could be bacteria, it could be something else going on. Lots of reasons. So medical science greatly improved by using the scientific method. All right, people, including myself, have biases, and a lot of times that clouds our perception of reality, and it's very pragmatic. Truth is a pragmatic thing. It's good. Maybe that's all I'll say about that. All right, well, I gotta get going. I got the quiz here. We're gonna do an experiment, and you'll get to practice the scientific method. That thing really lights up everything. Hopefully this will still be the way it is. So I got something here you can buy at the auto parts store. It's called heat. Pour it in your gas can and gets the water out. Primarily methanol. Oh wow, I got about 20 mils. Close that off. What do you know about methanol? Must burn in your car, right? Yeah, the methanol helps the water, soaks up the water, makes it soluble in the gas. We also say it's volatile. What does that mean? It evaporates readily. I got my hand on here. You might be able to hear the pressure. Y'all heard that, right? Built up some pressure. Is methanol flammable? Yes, let's see. That was fantastic. That was so fantastic. Let's do it again. I don't know what it is. Everybody's, yeah, chemistry, let's burn stuff, let's light stuff on fire. And I'm like, well, you could go to fire science, but I found then there's firemen who are also arsonists. What's up with that? All right. So in science, we want things to be reproducible. I want to do everything the same. So I got same volume of methanol, and I'm going to put that in there. I'm going to mix it up as before. I better ask the same questions. What did I tell you about methanol? It takes water out of gas.
Water vaporizes.
Yeah, it vaporizes. Let's see if we can. I almost think I feel some pressure. You hear it? Well, it wasn't as great, was it? All right. You'll have to take these gals word up front. Did you see a little flame for a little bit? Come on. I didn't shake it hard enough. You already saw me. Ooh, there it is. There it is. So, form a hypothesis. Big air-sucking flame. Some of you might have jumped. You went ooh and ah. Made noise. Ooh, the flame's still in there. That could be dangerous. All right. Form a hypothesis. Any fire science people? What does every fire need? Oxygen, right. I have a friend who's a firefighter, and he says every fire needs fuel, heat, and oxygen. So when they go to put one out, they try and deal with those, cool it down, get rid of the oxygen. All right, so yeah, oxygen. So sometimes I get, that made water. I can see there's a lot of methanol I didn't use. So typically I like to write on the board. Let me write on the board now. There's methanol, O2, H2O, and carbon dioxide. So the first time we had a bunch of oxygen inside the flask, nice fast flame. What do you think is in the flask now? Yeah, some H2O, but more importantly, that's what some of your fire extinguishers are made out of, right? So how can I get the carbon dioxide out of there? Displacement. This is the quickest way I found to do it. 20 years ago, I'd bring in this little aquarium pump and throw the thing in there and let it run. And I decided students want their money's worth. They don't want to. How do you like that? There should be no carbon dioxide in there anymore. It's real easy quiz. You'll have plenty of time to quiz. Alright, so the Greeks thought there was this element called air. When we figure out was in air? Oxygen, nitrogen, right. So we pushed all the carbon dioxide out and filled it up with water. More drama. It's gotta be, these are new. Normally they have a mute button. Yes! Nice one. They improved it. Everybody knows to stop, drop, and roll, right? I'm getting methanol all over my hand. If I was in a desert, maybe you could come see me. It's called Burning Man. Come on, Eric. Dr. May's like, I don't do the wash bottle. I've seen too many accidents. Well, and you can see how too much fun. Nice flame still in there. Somehow I think about it. Perfect. Combustion means to combine with oxygen. So the skeptical chemist, scientific speculation is worthless unless it is supported by experimental evidence. So this is by a guy named Robert Boyle. This is great. I'm thinking Monday we're going to start chapter 2. There's one more slide after this. So we talked a little bit about laws. This is the most fundamental chemistry law. I said many times a law might have an equation or numbers. So here's a guy named Lavoisier, French guy. He died in the Revolution because, back then if you could study science, that means you had a lot of money. Everybody else, they weren't as advanced as the Greeks. They had to go farm. Most of them were serfs, peasants. You get the idea. So, his house is looking nicer than my house. Look at that Greek and fancy molding. They like to burn stuff. We call it combustion. That means to combine with oxygen. Took sealed tubes, weighed them before and after burning the contents. Maybe lit the contents with a magnifying glass or something. Then he weighed at the end and he saw that the mass did not change. It might even look something like this. So if you weigh the reactants, have a chemical change, weigh the products, weighs the same. And we'll see how we can calculate masses of other reactants. Any questions?